Okay, 7.2 day 2, we're going to use long division to find the asymptotes. Okay, the long division is going to help get it into this format. In this format, where the denominator becomes 0 tells you where the vertical asymptote is. So the vertical asymptote is at x equals h. On this graph, you can see that this is the vertical asymptote, and we get that information from here. The horizontal asymptote, the horizontal line here, has to do with the vertical shift. So since there is a plus k at the end, the horizontal asymptote is at y equals k, which is a horizontal line right here. With those two asymptotes, the graph is quite easy to graph. We just need a point or two on each branch. Okay, so before we do the long division, let's just figure out the asymptotes. Okay, so the vertical asymptote, well, when this denominator becomes 0, we have a vertical asymptote, so that's going to be at x equals positive 3. And then because this graph is moved up 5, my horizontal asymptote is at y equals 5. And the x equals is what makes it vertical, so you have to have x equals. The y equals is what makes that a horizontal line. Okay, let's look at the next one. So in this case, the denominator will become 0 when x equals negative 7. And then because this graph is shifted down 3, there is a horizontal asymptote at y equals negative 3. Let's look at C. Y equals 7 over x. So to make the denominator 0, that would be at x equals 0. And then because the graph is moved down 4, my horizontal asymptote is at y equals minus 4. Okay, now for D, my vertical asymptote is going to be when the denominator is 0. Well, that's a little tricky to do in my head. So I'm going to do it to the side. I'm going to figure out when this is equal to 0. If I plus 5, I get 5. If I divide by 3, I get 5/3. So the vertical asymptote is at x equals 5/3. I am okay with you doing that in your head, but be really careful. Okay, now, is there a vertical shift here? There's not a vertical shift here, which means that the horizontal asymptote is at y equals 0, as it is on the parent function. Okay, now if it's in this format, we can get the vertical and horizontal asymptotes easily. If it's not in that format, it is to our advantage to put it in that format. Okay, so if I look at this right here, y equals 5x plus 17 over x plus 3, that's not in this format. There's two terms at the top, including an x. To put it in that format, I'm going to do long division. Okay, so when I do long division, let's remember. Okay, let me set it up. Okay, whatever is in the numerator goes inside the box. And whatever's on the bottom is what I'm dividing by. Okay, and then when I do long division, I pay attention to the first term here and the first term here. So if I want to multiply x by something to get 5x, I need 5. Okay, now I take the 5, I line it up above the like terms just because it helps me figure out when I'm done. I take the 5 and I multiply it by the x and the 3. So 5 times x is 5x. And then 5 times 3 is 15. And I line it up under the like terms. And then the one thing to remember is that we are subtracting down. Okay, so if I do 5x minus 5x, they cancel. And then this is 17 minus 15. If I do 17 minus 15, what am I left with? 2. Okay, let's rewrite this equation. Since it was y equals, I start with y equals. Y equals. When I divided, I got 5. So it's going to be 5. What was my remainder? My remainder was the 2. And then that was divided by x plus 3. Okay, which looks very similar to this format right here. So if you get used to these, you might start writing them in the opposite, like this. 2 over x plus 3 plus 5. Okay, now that it's in this format, what's the vertical asymptote? Well, that will be 0 when x equals negative 3. And then the horizontal asymptote, well, this gets shifted up 5, so the horizontal asymptote is at y equals 5. And that's what we're going to be doing for the rest of this example. Okay, so if you have started to get the hang of it, you're welcome to move ahead. I just am changing the signs a little bit and doing things like this. So this is 2x minus 3 over x plus 1. Since there's an x at the top, I can do long division. Okay, the top goes inside, the bottom goes on the outside. And then remember, we start out just by looking this and this. So if I have x and I want it to be 2x, I have to times it by 2. Okay, I like to line it above the like terms. 2 times x, 2 times 1. Okay, 2 times x is 2x. 2 times 1 is 2. And we're good. Okay, now the biggest mistake is when we subtract down. You don't have to write that you're subtracting, but you need to know you're subtracting. So if I do 2x minus 2x, they cancel, which is good. If I do negative 3 minus 2, negative 3 minus 2, I get negative 5. That's my remainder. Okay, now let's rewrite this in the correct format. This is f of x, so I lead with f of x equals. Okay, now I'm going to write it like kind of backwards until we get used to it. When I divided, I got 2. So this is 2 plus, what's my remainder? My remainder is negative 5 divided by x plus 1. Okay, now this format's fine. You might like to write it the other way just because that's more commonly how it's seen, but it doesn't make a difference to me. Okay, now that it is in this format, the vertical asymptote will be x equals negative 1. And then since this is moved positive 2, my horizontal is at y equals 2. Let's try the next one. G of x equals 4x minus 1 over x minus 1. There's an x at the top, so I can do long division. So I'm going to divide 4x minus 1 divided by x minus 1. First term is x and 4x, so I need to times by 4. 4 times x is 4x. 4 times minus 1 is minus 4. Perfect. Okay, subtract down. 4x minus 4x is 0. Okay, and then be careful. I'm doing negative 1 minus negative 4. So that's negative 1 plus 4. Negative 1 plus 4 is 3. Okay, now I'm going to write it in the order we sometimes see it. It's okay if you write it the opposite. Okay, I'm going to put the remainder first just because I know that's the fraction. So the remainder is 3 over x minus 1, and when I divided it, I got positive 4. Okay, so if you want to write it in this way, you can write it in this way. If these two terms are swapped, it doesn't make a difference to me as long as you know how to find the vertical asymptote. Vertical, x equals 1. The graph moves up 4, y equals 4. Okay, let's do a couple more. Okay. 3x minus 7 divided by x plus 4. First term, 3x and x. So if I times x by 3, I get 3x. 3 times x, 3x. 3 times 4, 12. And then just make sure you're subtracting down. 3x minus 3x is 0. Negative 7 minus 12, negative 19. Okay, so this was y equals, so I'm going to match the notation. Okay, if you would like to put the denominator, what's it called, remainder first, that's fine. If you would like to put it second, that's also fine. And then when I divided, I got 3. Okay, that's the format they want to see it in. Okay, what's my vertical? X equals negative 4, and then it got moved up 3, so y equals 3. Okay, let's do one more. Okay, h of x equals x minus 5 over x minus 3. So, okay, what's the first term? X. Well, they kind of already match. Let's put 1. 1 times x is 1x. 1 times minus 3, minus 3. Okay, just make sure you subtract. Okay, 1x minus 1x is nothing. If I do negative 5 minus negative 3, I'm really doing negative 5 plus 3, which is negative 2. Okay, so let me rewrite this. This function is h of x. Remainder, negative 2 over x minus 3, and then when I divided, I got 1. Okay, that's the format. And my vertical asymptote is x equals positive 3. My horizontal asymptote is y equals positive 1.